Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in this particular video, we are focusing on this particular paper, which is May June 2011 variant 11. And the question is about AP, GP, sum to infinity and trigonometry. So many things in one place. Let's look at the question. Let's focus on the first part. And let me start underlining this. The first two terms of an arithmetic progression are 1 and cos square x respectively. Show that the sum of the first 10 terms can be expressed in this form, a minus b sine square x, where a and b are constants to be found. So let's just focus on the first part. So now t1, that is 1, t2, that is cos square x. What is the definition of constant difference or common difference? That is t2 minus t1, which is cos square x minus 1. And this t1 is equals to 1, that is the first term. So we have a, we have d, we have n, that is 10. Therefore, sum of n terms, that is n divided by 2, 2a, n minus 1 in brackets multiplying with d. So this is 10 divided by 2, 2 into 1, n minus 1 is 10 minus 1 into d, which is cos square x minus 1. Let's simplify it further. This is 5, this is 2, this is 10 minus 1, that is 9. So 9 cos square x minus 9. And therefore this is 5, this is 9 cos square x minus 9 plus 2, which is negative 7. But I want it in terms of sine square x. So let me write over here, sine square plus cos square equals to 1. Therefore cos square is 1 minus sine square. So instead of cos square, let's write 1 minus sine square x. And then we have this 9 as it is, we have the 7 as it is, we have the 5 as it is. So this is 5 still on the outside, 9 minus 9 sine square x minus 7. 9 minus 7 is 2. So this is 5, 9 minus 9 sine square x plus 2. Let's open it up, negative 45 sine square x plus 10. Or it can be written as 10 minus 45 sine square x. Now this is in the form a minus b sine square x. So this is a minus b sine square x. It's a good idea to write it separately also. The value of a is 10, comparing coefficient, the value of b is 45. And let's double check. That is this thing. They have not written it separately. This is 10 minus 45 sine square x. All good, all clear. On the sidelines, they have written it. So the first thing is done and dusted. Let's focus on the second one. And the second one is this thing. The first two terms of a geometric progression. The previous one was AP. This one is GP. Is 1 and 1/3 tan square respectively, where theta lies between 0 and pi by 2. First part, find the set of values of theta for which the progression is convergent. Second part, find the exact value of sum to infinity when theta is pi by 6. Now this wording over here, progression is convergent, it means an infinite series has a finite sum. Now when an infinite series has a finite sum, sum to infinity exists. And what is the condition for sum to infinity? Common ratio lies between, let me remove this, common ratio lies between negative 1 and positive 1. So that is the condition. So let's start working. It's a GP. Of course, sum to infinity is related with GP. First term is 1, next term is 1/3 tan square theta. Common ratio is second divided by first, so 1/3 tan square theta over 1 is this much. Now, in order for the series to be convergent, common ratio should lie between -1 and +1. Now, this common ratio, 1/3 tan square theta, lies between -1 and +1. Let's slowly and gradually make theta the subject. -3 and +3 and tan square theta lies between these two. So now tangent theta lies between -3 and +3. Now there is a small catch over here. This is tan square theta, by the way. Therefore, tangent theta lies between negative square root of -3. Let me write it properly. Square root of -3 and square root of +3. But we know that square root of a negative number is imaginary, and we will study this thing in P3. They are called complex numbers. Therefore, it does not exist. So let me draw a number line. Over here, this is negative of √3. I'm writing √3, root of -3, my bad. And this is root of +3. And over here is somewhere in the middle is 0. That means this is not applicable. So therefore, now the question is changed, and now tangent theta lies between 0 and square root of 3. Now make theta the subject, that is tangent inverse of 0 and tangent inverse of √3. We know that tangent of 0 is 0. Therefore, tan inverse of 0 is 0. And we also know that tangent of pi/3 is √3. Therefore, tan inverse of √3 will give me pi/3. So therefore, theta lies between 0 and pi/3. We are restricted by this range that is related to acute angle. That is the first quadrant. And that is how this question is done. This was the difficult part which you have to think about. Now, the next one. First of all, this thing is done. All good. Part B, part 2. So I need more space, and that there is the space that I've created. Find the exact value of the sum to infinity when theta is pi/6. So now B part 2, the first term is 1, and then it's 1/3 tan square theta. But theta is pi/6, not pi/3, pi/6. Tangent of pi/6 is 1 over √3. Tangent of pi/6, the whole thing square, is 1 over √3 whole square, which is 1 over 3. And then we have 1/3 of tan square theta. So 1/3 of tan square pi/6. So 1/3 of 1/3, that is 1 over 9. All good, all clear. And the first term is 1. So far so good. So first term is 1. Common ratio is 1 over 9. Sum to infinity we are interested in. Find the exact value. Sum to infinity is a over 1 minus r. That is 1 over 1 minus 1 over 9. That is 1 over 8 over 9. Flip it. That is 9 over 8. Or it can be written as 1 whole 1 over 8. That is the answer. That is 9 over 8, or 1 whole 1 over 8. Or it can be written as 1.125, because that is in exact decimal. So this is exact. This is exact. And this is also exact. So any one of these three forms are acceptable. But always remember the famous saying, that is, fractions are beautiful. Fractions are exact. Fractions are supreme. So whenever you have a possibility of giving the answer, then fractions is mathematician's first choice. Take care, everyone.